So from an outline perspective, we want to talk about challenges. Why is modeling important? What's changed about the systems we developed over the last 10 to 15 years? And again, a refresh to say what are the things we face today, challenges we face today. Then we want to talk about the value proposition of modeling. Excuse me. Then we're going to look at the model-driven approach and go step by step across each activity in terms of requirements, analysis, design, block, sequence diagrams, etc., and talk about individually what their value proposition provides to the organization and to the entire system process. And then there's no free lunches. There are barriers to adopting model-based systems engineering, and we want to make sure that you all are aware of those barriers and ways to mitigate those types of barriers. So a little bit of background. Probably most folks here would understand what system engineering is. System engineering is a part of the life cycle, not really part of life cycle. It's a discipline within systems development that's really characterized, I like to think, around whole system thinking. So a lot of disciplines may be narrowly focused, or a lot of components or parts of a system may be narrowly focused. It's a responsibility and the job of system engineering to be whole thinking, if you will, thinking across the entire system. So their goals really are to understand what the system's supposed to do, what are its needs, what are its goals, design a solution, and then a strategy for execution to go meet those needs, and then serve really as a liaison. As we go embark on this process of understanding and designing and creating the system, there are constant discoveries that are made on literally a daily basis. And those types of problems, issues, and challenges, we don't want local solutions to them. We want to bubble those solutions up. Everybody has the stories. In fact, this is a recent story from just actually last month. I was working with a battery supplier to the avionics industry, and they were having challenges where folks on the hardware side would make minor tweaks to get boards to work or whatnot, but that would take them slightly out of spec. They'd hand those boards to the software people, and there would be a 2 or 3 week delay in terms of trying to understand why the software doesn't work on this new revocable board, only to find out that, well, some tweaking had gone on the other side, and you know, we didn't think we had to get a voltmeter out in the software side to actually make sure the board met spec. And it's challenges like that when somebody in a discipline or a part of the system detects a problem and they make a local fix. They may not understand the implications of that change and that modification downstream. And again, it's really the responsibility of the system engineering folks to manage, organize, and organize those folks toward the execution of the system. So again, the characteristics, they need to be interdisciplinary because they're thinking whole system. Their scope is really the entire life cycle. And a little bit to some degree, I think that's new to a lot of systems folks. System engineering a lot of time has been more the upfront spot thinking, and then we hand off our documents, our decisions to the downstream folks, and they should just be able to execute. But as I think we all have understood, you know, the last several years, the last several decades, the things don't go as planned. We make constant discoveries on these systems as we go build and execute them. So we continually need systems engineering involved, and the system engineering activities need to be thought of as more continuous across the life cycle of the system. System engineering also involves a lot of leadership, and the person I co-wrote this with, he calls it cat herding. And basically the idea there is that we need to make decisions, and we need to get the troops rallied around behind those decisions. Some decisions can be conflicting, and some can be controversial, and we need to provide some good leadership within that project or program to make sure we have everybody on the same page. What are some challenges that we face now with system engineering? Well, I think by far the largest is the complexity of systems that we build, and the cycle times associated with them have dramatically increased for complexity and decreased for cycle times. If we think about the complexity of systems we built just 10, 12 years ago, I mean, the analogy I always use is a cell phone, but there's a ton of them out there. Your gas pump, your ATM machine,